Now let's continue along with our example that we had with distributive property, and we're going to go a little bit further with this. One thing that confuses many students is when a negative number is out in front being distributed. You can read any negative number as saying the opposite of that number. So this could be read as the opposite of 2 times 3x minus 7. Or in other words, if this says two groups of 3x minus 7, then this just says the opposite of that. So over here I have pictured a group of 3x minus 7, and I use the little negative signs instead of the dots to remind me that once I've filled my 3 boxes, these are discs that I need to take out of that collection. If I do that twice, it looks like this, and you can see that I'll get 6x minus 14. 14. This is what 2 times or 2 groups of 3x minus 7 is. But what I want is the opposite of that. So to get the opposite of that means I'm going to actually, in fact, have negative 6x, or I'm giving away 6 boxes, and positive 14. I'm getting 14 discs back rather than taking them out. So when I distribute this negative, I have to remember that it's a negative 2 times 3x. And then I have a negative 2 with a negative 7. This becomes a positive 14 there that's being added with my negative 6x. So again, think opposite of, if that helps you, or just remember that the negative has to get distributed with that 2. Now, combining like terms. Again, I told you before that distributive property allows us to combine like terms, and this is what I meant by that. If I start with that same problem from our very first slide, that we combined like terms with pictures, but we try to do it just algebraically, the first thing we would use is our commutative property. That's the one that allows us to reorder. It says that if I'm adding 2 things and I switch their order, it's still going to come out the same. So this order right here does not have all my y's together, so I'm going to reorder them. I'm going to move them up and move the 5 and the 3x towards the end. My associative property says that if I have a bunch of stuff added together, I can regroup it and I'll still get the same answer. So in this scenario, I didn't have anything grouped, and now I chose to group everything with y together in one chunk. The distributive property in reverse allows me to see this common factor of y in each of these terms. And so I can imagine that somebody distributed the y to each of the terms, and I'm trying to pull it back out. By writing it like this, that y that was on each term now will only be written one time in this problem. And these are all constants that can be added together. I can simplify that addition within the parentheses and come up with an 18y. Typically, when we write an algebraic expression, we're going to write it alphabetically in terms of the variables. So the x term would come first, and then the y term, and finally the constant at the end. And so I can use commutative property to do that. Now, here are 6 problems. A couple different variations of the types of things we've done. You'll notice that in some of these, they might be more complex versions of something we've done. So please remember when you do this to follow your order of operations. If there's anything you can do in parentheses, do that first. You'll notice none of our problems here have exponents to worry about. Multiplications and divisions must be done before any additions and subtractions, unless these are in parentheses and can be simplified. And when we do those, remember it's left to right through the multiplications and divisions, and left to right through the additions and subtractions. So pause this right now and work out the 6 problems on your own. When you're done, hit play, and I'll walk you through how to solve them. All right, welcome back. As we look at this problem, here is our expression in parentheses being multiplied by 4. So every term in there will have to show up 4 times. So I'm going to have 4 sets of 3x, and I'm going to also have 4 sets of 6. So you should have ended up with 12x plus 24 for this first problem. This one's a little bit tricky because of the subtraction. Make sure that you did not combine the 12 and the 3, because that would be using subtraction before you dealt with the multiplication that's happening here. We have to take care of that multiplication first. So one thing we want to do is read this problem as saying 12, take away 3 groups of this stuff. So I'm going to start with my 12, and I'm going to take away 3 groups of 6. That means I'm going to take away 18 x's. If I take away 3 groups of 6x, I'm taking away 18 x's. Then I need to take away a minus 8 3 times. Take away 3 groups of minus 8. The double negative there, taking away a minus, means it's going to be plus or adding. And so I end up with a positive 24 there. This sign is the one that most people get wrong, because they miss that the minus in front of the 3 and the minus in front of the 8 together are going to make that a positive. Finally, we've got some like terms that need to be added together, and we end up with 36 as our constant minus 18x. And again, you could write it in the other order. If you did it that way, the 18x is negative, the 36 is positive. Remember, when changing the order, it cannot be reversed as subtraction. You have to think of it as addition. This is a minus 18x, so it is negative. Going to our next problem, again, very similar to the last one. We're going to distribute this subtract 5 times this. So we start with our 12. We want to subtract 5 groups of 9x. So that's subtracting 45x. Then we want to subtract 5 groups of negative 12 or minus 12. That's the same as adding 60. 5 groups of 12 is 60. And then just like our last one, we have like terms to combine. We'll get negative 45x plus 72. Or if you prefer, you could write it as 72 minus 45x. Again, the negative is in front of the 45, regardless where you place it in that problem. Down here, very similar to the problems we just did, except now instead of subtracting, we're adding, so it actually makes it a little bit easier. We do have this multiplication to deal with before we can add the 8 and 5. This says 8 plus 5 groups of this. So we have 5 groups of 9, that's 45, and then 5 groups of taking away 3x, or we're going to take away 3x 5 times. And that means we'll take away 15x. That subtraction is the only minus sign in that product, so it stays negative. Then we combine our like terms, the 8 and the 45, and we'll get 53 minus 15x. Or again, if you'd like to write it with the x part first, you could write it as negative 15x plus 53. This problem's a little bit trickier because of the 3x here. The process of distributing is the same, but getting the answer might be a little bit confusing for some. So I'm going to walk through the steps a little bit more clearly here. I've got a 3x times 12, and then only one subtraction sign, so it's going to say minus. And then I've got the 3x and the 4x. Notice I used the minus sign right here, so I'm not also going to put it there. This product right here really means 3 times x times 12. And because I can associate, which means regroup, and commute, which means reorder, these factors, I can rewrite it like this. 3 times 12 times x. And the same thing over here. This is a 3 times x times 4 times x. I can write this as 3 times 4 times x times x. So the 3 times 12 we know is 36x, and the 3 times 4 is 12, but x times x is x to the second power. So these two things are not like terms. Just like the 12 and minus 4x weren't like terms, When I distribute the 3x in, they don't become like terms. I would write it either the way that I have it right now, or I could rearrange it so the x squareds come first, the highest power first, and then the x's last. Our last problem here might have confused you at first because of where the multiplier is. This is 8 plus this stuff 7 times. So the 8's just being added to whatever we get over here. Over here, I want this entire chunk 7 times. So the 5x 7 times, I want to subtract 3y 7 times, and I want to add 2x 7 times. So if I take 5x 7 times, that's 35x. If I subtract 3y 7 times, I'm going to subtract 21y. And if I add 2x 7 times, I'm adding 14x. Now notice in this problem, I could have back here combined like terms, but since I didn't do it there, I'm going to do it now. I have 35x and I have 14x, and they're both adding 35x and adding 14x. So altogether, those two things can be just called adding 49x, or a positive 49x. We then want to add 8 and subtract 21y. So I'm going to write that I'm subtracting 21y and adding 8. And this would be my answer, alphabetically arranged with the x first, then the y, and then the constant.